the concepts relating to this next activity are that chemical reactions can produce changes in colour, something else we can observe when we mix chemicals together. And we're going to use this purple coloured chemical labelled, can somebody read the label? Labelled cabbage water. Where does it come from, I wonder? I made it earlier from cabbage, from a purple coloured cabbage. Sometimes called red cabbage. It's something you'll see in the supermarket. And I've got the purple chemical that's in this vegetable and dissolved it in water. So we're going to mix that with some other chemicals, vinegar and baking soda and water. And you could ask the students for their predictions what they think might happen if there's a chemical reaction when we mix them. What sort of changes do you think they might observe? And hopefully lead the discussion to in this one we're particularly going to be interested in what happens to the colour. And then you'll give the instructions of how to do the activity, and the students will go to the table and do the activity. At the table, the students will need to get these 3 small containers and put them on the 3 spots labelled vinegar, water and baking soda on the chart, and the chart tells them, the placemat tells them which chemical to add to each container first, and explain that they don't need to add too much, and they're going to unscrew the top of the valve of the vinegar bottle. And yes, explain that some experiments work better when we don't add too much chemicals, and demonstrate that they just need to add enough to cover the bottom of the container, enough vinegar to squirt in there. One person can do that. Once again, they're going to share the jobs in their group. Another person can add a similar amount of water to the middle one, where it's labelled water. And another person in the group can add half a teaspoon of baking soda. So in a previous experiment, we added a whole teaspoon of baking soda, but this time we're just adding a little bit, about half a teaspoon of baking soda, and they can just sprinkle that on the bottom of the other one. So one of them's got a solid in it, the other 2 have got 2 different liquids. And emphasise that they need to check those labels, and that's all they're going to add to each one. Vinegar to that one, water to that one, and baking soda to that one. And then the next person whose turn it is for a job is going to be the first person to add a little bit of cabbage water to the vinegar. And so they can add about the same amount of the cabbage water as the vinegar. A few squirts of cabbage water, as you can see, like this. And they need to look what happens, and then give it to somebody else in the group, and they observe what happens when they add a few squirts, a little bit of the cabbage water to the middle one, the water. And lastly, somebody will add a few squirts to the baking soda, and they will observe the changes. And they're very pretty changes. They might think they look a little bit like traffic lights. They'll now have 3 different colours have been produced. And once they've done that, you can get them to stop and say, come back to the floor to tell me what you found out before we do the last part of this experiment. And get them back to the floor. And then once they're back on the floor, ask them what they observed. What did you see happen? What changed? And which one changed colour? What colour did it change? That kind of thing. Which one didn't change colour? They'll often think this did change colour because it went a lighter shade of purple, but you can point out it's still purple, isn't it? So the water did not change colour. The other two, the vinegar turned it pink, the baking soda turned it green, bluey green, aqua, they might describe it as. And very briefly, you could ask them why. Why do you think that happened? Why did some of them change it, but water didn't? And it's because water did not react with the cabbage chemical. Vinegar did. There was a chemical reaction here, and then there was a chemical reaction with the baking soda. And in this case, the chemical reaction has caused the colour change. So that's another thing that can happen with a chemical reaction. And it's actually made a new kind of chemical that has a different colour. And then you can direct them to go back to the table to do the last part of the experiment. And the directions for when the students are back at the table is that they're going to try and change these two back to the original colour, the purple colour. And so they're not going to do anything to the middle one. You might want to get them to put that one out of the way. They're going to take it in turns in the group to pour a little bit of the pink one into the green one and watch what happens. And this time they'll observe the change of bubble formation and it's fizzing. And then the next person can tip a little bit of this one back into the pink one, and they'll see once again a little bit of bubble formation and fizzing. And they can keep going around in the group, taking it in turns, everyone watching what happens when someone has a turn, pouring it just a little bit at a time, just like a scientist, being careful. And you'll see them. Some of them are very reticent and will be only adding the absolute minute bit, and you might need to speed those people up a bit because they'll take a long time to mix this up. But they get very excited when they do this because they're actually changing the chemicals and they're changing it back. And they're both going purple. And they can keep going, taking in turns, have about 2 turns each, everyone in the group. And by that stage, they should have 2 nice purple solutions. And they'll be the same colour as this one. If they're not the same colour, you could, once they're back on the floor, you could discuss what colours they were. Some of them will find that, particularly the one that had baking soda, is still a bit green, or a bit blue. It'll probably be. It'll be a sort of dark blue, perhaps, with some of them, and that'll just be because they added a bit more baking soda than was ideal. They got a bit carried away and added a bit more than half a teaspoon. And if that happens, it will be a little bit. They won't be able to get it exactly back to purple because they won't have enough vinegar to neutralise the baking soda. But that's fine. It's just about observation in this. We're not too, at this level, we're not too concerned with the explanations about things and exactly what happens. It's just a sensory approach. But yeah, we could have a bit of a discussion about why they think that happened, and it's because you can explain it as the vinegar and the baking soda. It's that they like to react together. Some chemicals like to react together, and they get all excited when they mix together and they make a chemical reaction. But they're also like opposites, and they cancel each other out. So the pink colour of the vinegar and the green of the baking soda, when we mix them together, they cancel each other out and go back to the original colour. And you can introduce the terms acid, base, and neutral for the water, the acid vinegar, the alkaline or base baking soda, and the neutral water if appropriate, but it's probably not going to be necessary at this stage. And then we'll move on.